In this video, let's talk about the idea of deriving a final answer through the intermediate steps. So this is not new idea, but has been used in various problem-solving contexts, especially in the mathematical reasoning. So the key to this approach is to breaking down a complex problem into smaller, manageable steps. In the paper, Program Induction by Rationale Generation applied this idea to solve algebraic word problem by using natural language rationale, which is fascinating because it represents a structured way of reasoning through a problem rather than jumping straight to the final answer. So let's try to dive into a concrete detailed example which is based on this problem in the paper. Now let's break down the intermediate steps. The first step, we assign the variables, let the speed of the first train be the x meters per second, and let the speed of the second train be y meters per second. And then we calculate the length of the trains. The length of the first train in meters is equals 27x, since it takes 27 seconds for the first train to cross the main, and the speed is distance over time. And the length of the second train in meters is equals 17y, since it takes 17 seconds for the second train to cross the main. In the third step, we apply the condition when the trains are close to each other. So when these two trains are close to each other, they cover the total distance of the both trains combined. So the times it takes to cross each other is 23 seconds. And the fourth step is we simplify the equation step by step to derive the relationship between x and y, which is 27x plus 17y, which is equals 23 times the quantity of x plus y. And then we distribute the 23 on the right side, so we get 23x plus 23y. In the fifth step, we try to isolate x and y, so we group like terms to isolate x on the one side and y on the other side, which is 27x minus 23x equals 23y minus 17y. So this can be simplified to 4x is equals 6y. And the final step is we try to solve the ratio of x and y. So it's by dividing both sides of the equation by 2, which is x over y is equals 3 over 2. Thus, the ratio of the speeds of the two trains is x over y is equals 3/2. So the correct answer is B. So why this approach is revolutionary? The intermediate step in the reasoning, instead of directly jumping to an answer, the method makes this model generate the reasoning process in smaller, manageable steps. This mirrors how humans typically solve complex problems by breaking them down and logically solving each part. Now let's talk about natural language rationale generation. The approach, which is a sequence-to-sequence model, generates this breakdown automatically. So here is how to work with natural language rationale. So the first step is restate the problem. The model restate the problem in a way. For example, there are two trains crossing a main, and how they cross each other and time is taken, etc., so that it can understand the variable it involves. And the second step is define the variables. So the model assigns the variables x and y to the speeds of the two trains. And the third step is formulate equations. So this model uses natural language to break down the given times into distance-speed relationships and sets up the necessary equations. And the fourth step is try to solve the equations step by step. So this model performs algebraic manipulation, which explains each step in natural language. And the final step is derive the final answer. So after we simplify the equation, the model arrives at the correct ratio, which is 3/2, and explains how it arrived at this solution. The model they used is a sequence-to-sequence model, meaning it processes input the problem and generates the output, which is the reasoning and solution, as a sequence of steps. So it is trained on so many such problems, so it learns the structure of how to reason through them. And what is interesting about this approach is that they train the model from scratch on algebraic word problem, so it's unlike the modern models like GPT, which are pre-trained on a general language data. Their model specifically learned how to handle problems like the one above, which improving its reasoning for math-related tasks. Let's talk about natural language as a medium. Instead of just spitting out the final answer, this model explains its process in natural language, which making it easier for us to understand. So this is particularly helpful for subjects like math, where the steps are just as important as the final result. This is an earlier and critical step in making machines not just provide answers, but explain the reasoning step by step in a human-readable format. So this type of rationale generation has applications beyond math problem. The first is explainability in AI. So for an AI system to be trusted, they must be able to explain how they arrived at a decision, especially in high-stakes fields like healthcare and finance. And also in education area, the AI system is trained to provide rationales that can be used as educational tools, which is teaching students not just the answer, but steps which is required to get there. So their work demonstrate the power of integrating symbolic reasoning into machine learning, which enable models to reason through the problems in a structured way.